This is introduced before Chapter 13, the ideas of electrolytes or not. Sometimes this idea is confusing to students because they're not sure how to identify a strong electrolyte, a weak electrolyte, or a non-electrolyte. A, a strong electrolyte means that it conducts electricity well, which is why they give it the name electrolyte. And what it really means is you have a solution full of ions. So strong electrolytes tend to be strong bases, strong acids, or very soluble ionic compounds. Weak electrolytes then are weak acids, weak bases, or ionic compounds that are only partially soluble in water. And then covalent compounds that do not form ions at all are non-electrolytes, or if you have something not in water, not an electrolyte. So we're going to go through each one of these and we are going to determine whether or not it's an electrolyte. And the first one is sodium chloride. Sodium chloride is very soluble in water. If you look at a solubility chart, every group 1A metal is very soluble in water, and that makes it a salt and a strong electrolyte. Then C2H5OH is written several different ways, but it is ethanol, so ethyl alcohol. And it does not, it's fully covalently bonded, so it does not come apart into ions in water. It does dissolve in water, so they'll say it's miscible in water, but it doesn't form ions in water. So ethanol, number 2, would be covalent compound, not an electrolyte. H2SO4 is sulfuric acid, which is battery acid, and it's a strong acid if you look at the chart, which means that it fully ionizes in water, and those ions make it a strong electrolyte, and it's an acid because of the H in front. Number 4 is a metal hydroxide. Metal hydroxides are bases. Again, group 1, like sodium, lithium, potassium, they dissociate very well in water, so they form ions as soon as they hit water. Anything that forms ions is an electrolyte. This is a strong base. It's a strong electrolyte. Number 5 is actually sugar. And sugar is a covalent compound. There are no ionic compounds in there, which means it's covalent. It's not an electrolyte. If we look at number 6, calcium iodide, it's an ionic compound. So then we need to determine if it dissolves well in water. And if we look at a solubility table, the group 2 calcium is not as clear as the group 1 with sodium, potassium, lithium as far as solubility. But it does say on the solubility chart that halogens are very soluble unless they're with silver, mercury, or lead. So this would be very soluble, which means it dissociates into ions. So it's a salt and it's an electrolyte. And they start calling anything that's an ionic compound a salt after a certain point in your book, after actually chapter 5, naming. HF is hydrofluoric acid. And hydrofluoric acid is a weak acid in water, so it's a weak electrolyte. Again, weak acids, weak bases, automatically weak electrolytes. Also, compounds with only partial solubility in water. Magnesium hydroxide. Magnesium hydroxide is a base. It's a metal hydroxide. It dissociates well in water, so it's an electrolyte. Ammonia is a weak base, and you would get this from looking at a table, or you would memorize your weak acids, weak bases, strong acids, strong bases. And ammonia is a weak base, which is going to make it a weak electrolyte. And then number 10 is acetic acid. There's 2 different ways to write acetic acid. This is one way. The other way is just to say HC2, C2O2, H4 is another way, so you can see it written all together. Acetic acid is a weak